is the following statement going to be true? That for all integers a, b, and c, if a divides b and a divides c, then a divides b squared minus 2bc minus c squared. We've already done three similar problems to this where we had this be two addition signs, this be a negative and this be a positive, this be a positive, this be a negative, and we found that all three of these were true. So now we're doing the very last option, which is this fourth option, and I'm gonna say that this is likely going to be true because the other three were true, but I'm still not sure. Let's try and think. Can we think of any examples where this won't be true? I can't think of any. Let's just do one. Let's do the very easy one of 2 and 2 and 2 and 4. So then we ask ourselves, does 2 divide 2 squared minus 2 times 2 times 4 minus 4 squared? And the answer is definitely. You can definitely factor a 2 out of all of these, right? So this is going to be the same as asking 2 divides 2 multiplied by 2 minus 2 times 4 minus 2 times 4, right? Fantastic. Oh, and let's close the bracket. So it is going to be true. What's on the right-hand side probably can be written as what's on the left-hand side, or sorry, the right-hand side can be written as a multiple of the left-hand side, or whatever's on the right of this line can be written as what's on the left-hand side multiplied by some integer, right? For clarity, let's just quickly compute what this would have been originally. So this would have been the same as asking, does 2 divide 4 minus 2 times 4 is 8 times 2 is minus 16, and then 4 squared is 16 times negative 1 is going to be negative 16. So it's going to be the same as asking 4 minus 32, which is going to be 2 dividing negative 28, which is going to be true because negative 28 is a multiple of 2, because negative 28 can be written as 2 multiplied by some integer m, where this integer m would obviously have to be negative 14. So all we have to do is verify that whatever was here is in fact equal to negative 14. So this is going to be the same as saying 2 minus 8 minus 8, and that is in fact going to be negative 14. So fantastic. We got this. Notice we have times 2 times 2 times some integer m we know is negative 14, and we know this is equal to negative 14. So it's looking like this statement is in fact going to be true. Let's go ahead and try and prove that. So this is a for all statement, which means how do we start all of our for all proofs? Well, we start by saying let. So we say let a, b, and c be integers such that a divides b and a divides c and a cannot be 0. If you're not sure why I added this last bit in, try and compute something like 0 divides 2 or 0 divides some integer k. See what problems you run into. Hint, it's going to be dividing by 0. That's going to be the problem you run into when you let the left-hand side equal 0. Anyways, now we probably want to define mathematically, not mathematically, but in like a mathematical equation of some kind, what it means for a to divide b and for a to divide c. So let's go ahead and do that. We can say then b can be written as a multiple of a, or b can be written as, what letter do I want to use today? Let's use q. And c can be written as a multiple of a, or c can be written as a multiplied by, let's use v. And of course, q and v have to be integers here, so we have to explain where q and v are integers. Fantastic. Now, let's go ahead and try to see if the right-hand side can, in fact, given these rules, be written as a multiplied by some huge bracket where whatever is in this bracket is going to be an integer. So we say next, or let's use thus. I've been using very similar language throughout this series so far, so let's change it up a little bit. Thus, b squared minus 2bc minus c squared is the same as saying aq squared minus 2 times aq times av minus av squared, which is going to be the same as, well, actually, I don't need to do a whole lot more. you should immediately be able to see you can factor 2 out of all of these. So this is going to be the same as saying a multiplied by aq squared minus 2 times qav minus av squared. Fantastic. Notice that this is going to be an integer, most likely a negative integer, but we don't know that, so we're just going to say it's going to be an integer. My intuition just tells me it's probably going to be negative, but negative integers are still integers. Maybe there's an example where it's not, where q maybe is really, really large, but besides the point. Anyways, so we can just basically acknowledge to the reader, so aq squared minus 2qav minus av squared is going to be an integer. Then we say, in conclusion, so because we've shown that b squared minus 2bc minus c squared can be written as a multiple of a, we say, in conclusion, b squared minus 2bc minus c squared is a multiple of a. I'm not going to explicitly explain why. I'm not going to say because it's equal to this, and this is a times an integer, so it's a multiple of a, and by definition of divisibility means the statement's true. I'm not going to say that. That's very extra. You've already shown that up here. So this is going to be the proper proof, the concrete, the concise proof you should be writing. In conclusion, b squared minus 2bc minus c squared is a multiple of a. So a does divide b squared minus 2bc minus c squared, or we can say so is true. Fantastic. We have now proven that this statement is in fact going to be true.